I've seen many confusions on these concepts which I think need to rectify. We need to clarify what those concepts are, and what they are not. Some commonly observed phenomena or combinations of those two. I think that the confusion occurs because some experiments frequently introduced to demonstrate those phenomena involve both of them simultaneously, such as single-slit and double-slit experiments. Showing experiments that demonstrate each phenomenon independently will help a lot in recognizing the difference. Diffraction of light is the bending of light as it passes around the edge of an object with higher opacity than the medium, towards the area/volume behind that object. The amount of bending angle and intensity of bent light depends on the opacity and shape of the object. Opacity and penetration depth depends on the frequency of light as well as the material of the object. In single-slit diffraction, the two sides of the slit act as two sources. If the slit is smaller than the wavelength of light, it effectively becomes a single-point source, and no observable interference pattern occurs. Interference is a phenomenon in which more than one waves combine to form a resultant wave of greater or lower amplitude which are resolved spatially. It's because different places receive the original waves in different phases. To produce observable interference pattern, the original light waves need to have the same frequencies and similar polarization. When the amplitude difference is resolved temporally, it is called beat. It is caused by slight difference in frequencies of original waves. When the frequency is significantly different, what we'll get is color mixing. The variable amplitude is unnoticeable. When the polarization axes are different, we don't get visible destructive interference, although they do superpose. Thin film interference is a combination of refraction, reflection, and interference. No diffraction is involved. Light dispersion occurs in the same experiment when incoming light waves have more than one frequencies. Another example of interference without diffraction is Lloyd's mirror. The interference pattern is produced by superposition of reflected light with original light beam. Beam splitter can also produce interference without involving diffraction. Device misnomer also contributes to the confusion. Historically, diffraction gratings were made of opaque materials, such as bird feather and hair. They do produce interference pattern through diffraction. Modern diffraction gratings are made of transparent materials, such as glass and plastics. They can also produce interference pattern through refraction as well as reflection.